Okay, this is going to be the first lesson in Unit 2 for pre-calc. Okay, we want to start with these, what they call parent graphs. Okay, all right, and what the parent graph means is basically a graph of parent function, all right, is the function without numbers. Okay, now for the interest of our graph, our anchor point for our parent functions will be 0, 0. Okay, will be 0, 0. And we'll talk about how that changes with numbers. But one thing we want to look at is how to make the table. Okay, so with a parent graph, you're gonna make a table for each thing. Now your table is going to have one number to the left of the anchor, two numbers to the left, and two numbers to the right of the anchor point. So we're always going to start with these. There's a couple exceptions we'll get into. And what you're doing is you're taking this number and putting it in for x. So 1 squared would be 1, 2 squared would be 4, negative 1 squared would be 1, negative 2 squared would be 4. Now, how do you graph it? My anchor point is 0, 0. So from the anchor point, this means 1 right, 1 up. So from here, 1 right, 1 up. This means from the anchor point, 2 left, 1, 2, 3, 4 up. This means from the anchor point, 1 left, 1 up. This means from the anchor point, 2 left, 4 up. And you get something that looks like that. Okay? All right, little round quadratic. Okay? This one, okay, is a cube. Same values, 1, 2, negative 1, negative 2. So 1 cubed would be 1, 2 cubed would be 8, negative 1 cubed would be negative 1, negative 2 cubed would be negative 8. Okay? Remember the concept we talked about last unit of cubes. Okay? So it's 0, 0, that means I go 1 right, 1 up, 2 right, 8 up, which would be here, 1 left, 1 down, 2 left, 8 down. So this is what this graph looks like. Parent graph looks like. Okay? For absolute value, 1, 2, negative 1, negative 2. Absolute value of 1 is 1, absolute value of 2 is 2, negative 1 is 1, absolute value of negative 2 is 2. Okay? So the relationships with the points. Once again, 0, 0, 1 left, 1 right, or 1 right, 1 up, 2 left, 2 up, 1 left, 1 up, 2 left, 2 up. So this is what my graph looks like for that. Okay? Now, for the square root function, if I were to use those same things, okay, square root of 1 is 1. Now, square root of 2 would be a decimal, so that doesn't help us. Square root of 3 would be a decimal. Square root of 4, though, would create a result of 2. So that would be 2 points that I could use. Now, for these, I can't have a negative square root, so those are out, okay, because I get the imaginary number set. So 1 over 1 up, 4 over 2 up, so this is what your graph looks like, okay? All right. Okay. Now, what this is called is the step, or some people call it the greatest integer function. Now, your steps are always going to look like this. Okay? Closed circle to open circle. Now, why is that? Let me explain the greatest integer function. Let's say we were looking and making a table 1, 1.2, 1.5, 1.9, and 2. Okay? What the idea behind the greatest integer function, if you had a person.
Mr. Ma, if you're in the building, please call extension 3020. Mr. Ma, if you're in the building, please call extension 3020. Thank you.
Okay? If you were walking along, greatest integer means always left to right. Okay? So as I go from left to right, if I'm at 1, then I'm going to be at 1. Okay? At 1.2 would be like right here. The greatest integer I actually pass is still 1. If I were to walk to 1.5, the greatest thing I pass is 1. Okay? And at 1.9, the greatest thing I've still passed is 1. Okay? Now, once it changes is when I get to actually 2, it jumps to 2. So as you can see, if I were to plot all those out, okay, 1 over, 1 up, 1.1, 1, 1.5, 1, okay, they all basically create a step there, okay, and then it would change once I got to 2, okay. So to make the greatest integer function, we're still using these values. They're just 1, 2, -1, -2. Okay, and I just draw little steps. Okay, and that's how you make the greatest integer function. But that's sort of the concept, is that as you're walking through there, the greatest integer you pass is that one. Okay, this is a rational function. Okay, so if I put 1 in there, it would be 1. 2 is 1 divided by 2 would be a half. -1, -0.5. Now, for the rational, it's a little bit different. Our anchor point is going to be 2 asymptotes. Okay? All right? So 1 over, 1 up, 2 over, a half, 1 left, 1 down, 2 left, a half. So this is what your graph looks like. Okay? All right? So you end up having, okay, that for the rational graph. Okay? Now, let's talk about, so this change. Let's talk about changing the anchor point. Okay? So let's say I had these examples. Okay? Absolute value, x plus 2 minus 4. That. Let's say I have that. Let's say I have that. Let's say I have this. And let's say I had this. Okay. So as you can see, we've introduced a bunch of different numbers into our function, okay? Now what this is going to do is it's going to transform, that's why the term transformation, of my anchor point, okay? So what we want to do, we're going to identify the transformation and the anchor point. Okay, now, here's how easy that is, the transformation. It's probably easier to get the anchor point, honestly, first. Okay, so the idea is, whatever is inside, this will affect the x coordinate, and it will be opposite of what the sign is. This part right here will affect the y coordinate, and we're going to follow that sign. So the idea here is opposite of 2 plus 2 would be -2, opposite of that would be -4. So what is happening there? We're going 2 left, 4 down. Okay? Very simple. Sometimes it's easier to get the anchor point and then get the transformation. So that's what's happening, is the graph is shifting, and we'll get into how to graph in a little bit. So this one, opposite of -1 will be +1, that's going to stay -6. So what does this mean? We're going to go 1 right, 6 down. Okay? Now, this one, as you can see, only has something there. The opposite of +6 would be -6. There is nothing out here. I'll talk about this too in a second. So that would be 0. Okay? So what we're going to do is go left 6. Now, what this number is out here is a dilation. Okay? So we're going to have a dilation of 2. And basically what that's going to do is we're going to multiply our y's by 2. Okay? We'll talk about that in a second. Okay? Let's go to this one. As you can see, there's nothing inside, so there would be a 0 there. This is going to be -5. So what's going to happen is we're just going down 5. Okay? Now, let me talk about what this is. When it's negative out here, you have a reflection. Okay? So basically, I'm going to multiply the y's by -1. And once again, we'll show what that means graphing in another lesson. Okay? Now this one, all right, as you can see, I've got only stuff going inside there, so that's going to be -6. Okay? All right? I'm sorry, negative 1. I was looking at that. Okay, and there's nothing outside of there, so that'd be 0. Okay, so what's that mean? Left 1. Okay, now this right there, it's a fraction, it's a dilation of 1/2. And basically what we're going to do is we're going to multiply our y's by 1/2. Okay? This last example, the rational, this is considered that part of the inside. So this would be 5, that outside would be 6. So we're going right 5, up 6. Okay? And that's how we identify the transformations. Okay? So here's what I like you guys to do. Okay? Okay, identify the transformations. And anchor point. Okay? And here are the questions I'd like you to do. Okay, so go ahead and pause the video and work on these, okay? And then we'll go ahead and go over them. Okay, go ahead and unpause your video. So what would happen here is my anchor point opposite of negative 9 would be positive 9, and this would stay negative 2. So I am going right 9, down 2. Okay, pretty simple. All right, the opposite of positive 4 would be negative 4. That will stay negative 5. Okay, so that's going to be left 4, down 5. Okay, this one I got a bunch of stuff going on. So if I look at that, that would be 3. That's going to stay 6. Okay, so I'm going right 3, up 6. Now, got a couple things. I got a dilation of 5, and I got a reflection. Now, what I'm going to do though is I'm going to take my y's and I'm going to multiply by negative 5. Okay? All right, like I said, we're going to practice those in a little bit. If you understand what's going on here, it's actually pretty easy. Okay? All right, let's go to this one. I got nothing inside of there. There's no parentheses. So I would have a 0, and this would be an 8 right there. So I'm just going to go up 8. Okay? Now that 1/4 is a dilation, so a dilation of 1/4. Okay? So basically I'm going to multiply the y's by 1/4. Okay? All right, let's go to this part. Okay? This one would just be opposite of negative 9 would be positive, and that's going to stay that. So this would be right 9, up 2. Okay? This one, all we have is something in there, nothing outside there, so that's just going to be right 8. And so what I got a couple things going on there. I got a dilation of 1/4, and I got a reflection. Okay, so what I would do is I'd multiply my y's by negative 1/4. Okay? All right, and that gives you a foundation, in my opinion, of how to graph. And now we're going to apply those in the next lesson.